Okay, now we're going to talk about normal distribution, and then we're going to apply normal distribution. So what is normal distribution? Well, it's just a way for us to visualize and analyze data and to determine probabilities. And normal distribution is probably one of the most common distributions. If you look at the picture here on the figure, it takes on a bell-shaped curve. All right. And the normal distribution is characterized by the probability density function that you see here. It says f of x equals 1 over sigma times the square root of 2 pi times e to the negative x minus mu squared over 2 sigma squared. So we're going to discuss what those little components mean in just a second. But what I'm getting at here is that a lot of data takes on this bell-shaped curve. I mean, if you talk about maybe people's IQ, you talk about maybe height, rolling a dice, tossing a coin. Those are some different things. Maybe even sometimes income distribution in a country. Think about the United States, for example. I think the United States economy and really income distribution follows this bell-shaped curve. Think about it. You have a large middle class here in the center. You have some area where maybe wealthier people are a smaller proportion, whereas poorer people a lower proportion of the population. So it follows kind of a bell-shaped curve there. There's different ways to apply normal distribution in the real world, and we're going to take a look at one example. But let's go ahead and talk about the components of the normal distribution. Okay, so what we're talking about here is we're going to be talking about the mean and the standard deviation. All right, the mean is characterized by this, what we call the mu. All right, the mean is this mu value. All right, so mu, this is the mean. All right, this is basically the mean that all right, an average of the values of the data. All right, so think about mean and you can average, correct? Now, let's talk about what the standard deviation is. Well, the standard deviation is a measure of variance, okay? How far away something is from the mean, all right? It is a measure of variance, but variance is what we call sigma squared. All right, variance is what we call sigma squared. So I won't talk about that because we're really going to be talking about sigma, the standard deviation. So this represents a measure of how far away a particular number is away from the average value, from the mean value. All right, so we're going to be, without getting too more technical into this, we're just going to read our problem here and we're going to fit it to this function here that they gave us. All right, we're going to fit it to that problem there, and we're going to try to apply what it is that we learned from this. Okay, so it's really nothing difficult. All right, it all centers around this probability density function. So let's go ahead and take a look at that. All right, so we're here with this problem we're going to call number 11, and it says a physical fitness association is including the mile run in its secondary school fitness test. The time for this event for boys in secondary school is known to possess a normal distribution, and this is what enables us to use that PDF that we discussed earlier. All right, a normal distribution with a mean of 450 seconds. So here is the mean. All right, and a standard deviation of 50 seconds. So here's the standard deviation. All right, if you are given, for example, a variance, all right, you're going to want to take the square root of that. But in this case, it says find the probability that a randomly selected boy in secondary school can run the mile in less than 335 seconds. So right here, this is what we're going to need in order to figure out what it is that we need to integrate. So what they're asking us here is they're saying, what is the probability of the event occurring in under 335 seconds? So we're going to need that information. So let's write down what it is that we know. Well, first of all, we know the mean. All right, it was given. It's mu, it's 450 seconds with a standard deviation of 50 seconds. All right. And we're asked to find the probability of the event occurring under 335 seconds. So it's real simple. We're going to state at the end, after we get our answer, we'll state what this means. Okay, we'll state what it means. All right, we'll give our interpretation, if you will. So let's go ahead and take a look at the integral here. We're going to integrate from 0 to 335 because we assume that this is going from 0 to 4, well, 0 to beyond 450, because 450 is the mean. So we're going to integrate any values below 335, okay? Because the least amount of time that it could possibly take is 0 seconds, but of course that is not reasonable. So let's say 0 seconds to 335 seconds to run a mile, and then the standard normal, I'm sorry, not the standard normal, but the normal distribution here that we discussed. So let me put that into focus for a second so that you know what it is we're doing. So it says 1 over sigma. Sigma in our case is 50. All right, times the square root of 2 pi. All right, and then we multiply that by e raised to the power of negative, and then I have x minus mu, which our mu is 450. Quantity squared divided by 2 sigma squared. 2 times 50 squared. All right, and then of course dx. All right, we can't forget that famous x. All right, so we've got this right here. This is what we're going to head and integrate, but we're going to utilize a computer algebra system. So we're going to toss this integral here into Wolfram alpha, and let's see what we get, and then we'll give an interpretation. All right, so let's check. Okay, so taking a look here at our problem, and our Wolfram alpha output, and I want you to notice something, and you might want to pause it. Okay, it's quite a bit to type out. Right, so just be very careful when you're working on Wolfram alpha. All right, but if you notice, I crossed something out here, and let me just reveal it really quickly. This is some technical jargon, an error function, so we're going to disregard it. We really just care about what the output is of the integral, and so I'm going to write it out here, and it is 0.0107. All right, we'll take 4 decimal places and we'll record that as our answer. But let's give an interpretation. What in the world does this mean? Well, we're talking about this physical fitness test, and we're trying to find the probability of an individual that can run the mile in less than 335 seconds. All right, so what is the probability? All right, this 1.07 represents the percent, okay, of secondary school boys. So let me write this down, and I'm going to write down interpretation because that's important. Interpretation, because you have to understand what the data means exactly. So what does this represent? It says about 1.07%, okay, because this is the proportion of the population there. About 1.07% of secondary school boys can run the mile in less than, what was our investigation? In less than 335 seconds. So what you do here, and I want you to notice, is that I used the question, and maybe it wasn't so much a question, but the investigation, find the probability. I used that, all right, in order to write and interpret my answer. So oftentimes when you're trying to interpret something, go back to the question that was being asked, rephrase, restate, so that you have some meaning given to your answer. All right. So as always, I hope this video was helpful, and remember, like and subscribe.